Welcome to the 27th lecture of Digital Electronics subject. In this lecture, we'll be reading about how a Boolean function can be represented using different forms. The different forms of representation of a Boolean function are: first one is sum of products form, SOP, that is sum of products form. Second one is POS, that is product of some form. Third one is truth table form. Fourth one is standard sum of products form. It is also known as disjunctive canonical form. Then fifth one is standard product of sums form. That is known as conjunctive canonical form. Okay. Now the sum of products form is also known as disjunctive normal form. That is DNF. And product of sum is also known as conjunctive normal form. That is CNF. Then sixth one is using Venn diagram form. Then seventh one is using Carnot map. This Carnot map is also known as K-map form. Okay. So basically these seven are the representations of how you are representing a Boolean expression. Okay. And if you are having octet representation is also there, but that is not covered in our syllabus. Okay. So these are the basic forms of representation: SOP, POS, truth table form, standard sum of products form, standard product of sums form, Venn diagram form, and Carnot map form. Okay. So let me start with sum of products form. Okay. Sum of products form. That is, first one is sum of products form. Okay. Or it is SOP. Or it is also known as disjunctive normal form. That is DNF. So here the general principle is, if you are having a function given by 3 or 4 variables, f of x, y, z, etc., where x, y, z are Boolean variables, then the way to represent it is in sum of products form. That is, for example, if I am having x, y, z as f of a, b, c, can represent as a or b. That is sum. Okay. That is sum. This is also SOP form. Or I can write as if another example is AB is a product. Okay. And BC is another product. Okay. So I can write f of ABC. I can write it as AB or BC. This is basically sum of products form. Okay. This is basically sum of products form. Okay. So hope you have understood. Another example is if it is f of xy z A. You can write it as AXY plus BZ X plus B bar YZ plus A bar XY. Okay, this is also in the form of sum of products form. Now see, the basic disadvantage of the sum of products form is that it will not contain the entire terms or entire combinations of the elements which is present in the function. That means here using f of x, y, z and a, if there are 4 variables, we can have 16 combinations. That 16 combinations may be present or may not be present. Okay, so that is the basic concept of sum of products form. Okay, so coming into second one is product of sums form. Product of sums, or it is known as POS, or it is also known as conjunctive, normal form. Okay, so if I am writing an example, I can write this product of sums. If I am writing an example, I can write it as f of a comma b comma c is a or b and a bar or b or c. So this is sum, this is also sum. So you can get this is the product. So what will you get it as? This is sum of products form. Sorry, it is a product of sums form. This is product of sums form. That is an example. Okay. So here, here again the same thing is there. So if I am writing f of ABC, I can have 2 raised to 3, 8 combinations of it. If I am having 8 combinations of this ABC, then no need to have the entire combinations in this in the pattern. Okay. So you can have any other pattern, but only thing is this is it should be in the form of sum of products. Okay. Sorry, not sum of product. It's a sum of product of sums. So 2 sums are there. You should get the product. So that is an example of product of sums form. It is also known as conjunctive normal form or CNF. Now coming to the third one. Okay, so we will deal with this POS and SOP forms in the further lectures in detail. So third one is truth table form. Third one is truth table form. Okay, that is what you already know. For example, if I am having f of ABC as a bar b or bc, a function, so you should represent it as a truth table like inputs and outputs. Okay, input. Okay, so there are 3 inputs, A, B and C. Okay, so I have done, if there are 4 variables, okay, if there are 4 variables, there will be this one 2 power 3, 2 power 4, sorry, you will get 4 variables means we can go up to 16. Yeah, you can have 16 combinations. So there is 3 variables, we can go up to 8 combinations. And here there are 3 variables, so you can go up to 8 combinations. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. So you have 8 combinations here. Okay. So to get the output, first you need to find A bar B. First you need to find A bar B. What is A bar B? 1.0. 1.0 is 0. 1.0 is 0. 1.1 is 1. 1.1 is 1. 0.0 is 0. 0.0 is 0. 0.1 is 0. 0.1 is 0. So that is A bar B. Now coming into BC. Okay. 0.0, 0, 0.1, 0, 1.0, 0, 1.1, 1, 0.0, 0, 0.1, 0, 1.0, 0, 1.1 is 1. Now if you are getting the output, okay, output that is X, that is equal to A bar B or BC. Okay, so you can order it 0 or 0, 0, 0 or 0, 0, 1 or 0, 1, 1 or 1, 1, 0 or 0, 0, 0 or 0, 0, 0 or 0, 0, 0 or 1, 1. Okay. So this is basically the truth table type representation. This we can write it as a function of a comma b comma c. So here what you have to do is you have to draw the entire truth table, including the variables of the inputs and the corresponding outputs. Okay. So this is basically the truth table form of representation. So coming to fourth one. Fourth one is standard sum of products. Standard sum of products. Okay. So it is also known as disjunctive canonical form. Disjunctive canonical form, that is DCF. Okay. Now here what I am having is, if there are n variables, you should take all the possible combinations of the variables, and make it into this one, sum of products form. Okay. So how to obtain it? I will show an example. If I am having a function f of a comma b comma c given by a bar b or b bar c. See, this function consists of only two terms. Okay. But there can be different other combinations of that. Okay. So how to go with different combinations of that? See, in this term c is not there, and in this term a is not there. So how to make? So you have to get it as a bar b or and c or c bar, or b bar c and a or a bar. Okay, because in the first term c is not there, in the second term a is not there. So you have to multiply with the corresponding term. So if you need to multiply c, you have to multiply by c or c bar. So here what will you get? You will get a bar bc or a bar bc bar, or then here you will get a b bar c or a bar b bar c. This gives the standard sum of products form. This gives the standard sum of products form. Okay. So hope you have understood how to obtain the standard sum of products form. Okay. Now, now each term. Now if you are considering the each term of SOP, each term of standard sum of products form is known as min term. Each term of standard sum of products form is known as min term. Okay. So there is a general definition of min term. How to represent these min terms, that I will take it shortly. Okay. So here in the next step, in the next one, I will show how to represent a min term. Okay. Then after that we will go with standard product of sums form. Okay. So I will take this example only. So I am having f of a comma b comma c. F of a comma b comma c, I am writing it as a bar bc. This a bar bc, I am writing the standard SOP form, that is a bar bc or a bar bc bar, a bar bc bar, or a b bar c, a b bar c, or a bar b bar c, or a bar b bar c. So if you are writing the Boolean values directly, okay, you will get 0, 1, 1. So this is 0, 1, 0. This is 1, 0, 1. Yeah. Okay. This one is 0, 0, 1. If I am taking the decimal values for 0, 1, 1, it is 3. Here you will get 2. This is 5. This is 1. Okay. So write it in the ascending order. So you can write f of ABC as sigma m. Write that values in ascending order. That is sigma m 1, 2, 3, and 5. Okay. Or you can write it as m0. You can write it as m0. Sorry, m1, or m2, or m3, or M5. Okay. Now what is M1? This term is M1. This term is M2. This term is M3. This term is M5. Okay. So hope you understood the representation in min-term form. Okay. So I will show one more example in standard sum of products form. So that is the first example I am showing here. This is the first example. Coming to the second example. To obtain the standard sum of products form. So I am giving f of a comma b comma c comma d. I am writing it as say ab bar or abc or cd bar or abd. Okay. So now I need to write this one in standard SSOP or standard sum of products form. So in the first term, which is absent, C and D is absent. In the second term, D is absent. In the third term, A and B is absent. So here C and D is absent. Here D is absent. Here A and B is absent. Here C is absent. So I can write f of a comma b comma c comma d like this. That is a b bar and c or c bar and d or d bar, or in this term d is absent. So this abc into d or d bar, then or cd bar and a or a bar and b or b bar, or abd into c or c bar. Okay. Now just expand it. If I need to expand it, so first you open the brackets first. So you will get ab bar into cd or cd bar or c bar d or c bar d bar, or abcd or abcd bar or cd bar in and ab or ab bar or a bar b or a bar b bar and abcd or ab c bar d. So write in the corresponding order. Now again expand two brackets, that is a b bar c d or a b bar c d bar or a b bar c bar d or a b bar c bar d bar or a b c d or a b c d bar or again you will get a b c d bar or a b bar c d bar or a bar b c d bar or a bar b c d bar or that comes only one. Okay. Or a bar b bar c d bar or a b c d or a b c bar d. This much terms is there, but we can simplify it. How to simplify it? We'll take another color. A b c d is here, a b c d is there here. Okay, that two terms can be simplified into a single term. Again, any other terms is available for simplification. A b bar. Okay, so we will a b c bar d. Okay, so that you can write it as a b bar c d. So that is equal to a b bar c d or a b bar c d bar. Yeah, you can get a b bar c d bar, these two terms. So that will become only a b bar c d bar. Or what is the next term? Next term is a bar b bar c bar d. A bar b bar c bar d. Yeah, you get a bar b bar c bar d or So this term over, these two terms over, a bar b bar c bar d, that term is over. Then next one is a b bar c bar d bar, a b bar c bar d bar. Okay, so this term is over. So then a b c d bar, a b c d bar and a b c d bar. So these two terms can be combined to a single term, that is a b c d bar or a b c d bar. Then so that two terms are gone. So that's it. Then a bar b c d bar or a bar b c d bar or b c d bar or a bar b bar c d bar, a bar b bar c d bar, or last one is a b c bar d, a b c bar d. So if I am writing that, if I am writing the other part, that is writing it in 0 1 form, that is 1 0 1 1. This becomes 1 0 1 0. This 0 0 0 1 0 1 0 0 0. This is 1 1 1 0. Then this is 0 1 1 0 0 0 0 1 0 1 1 0 1. Yeah. Okay. So which are the terms you got? You got it as 1 0 1 1, 1 0 1 1, or 1 0 1 0, or 0 0 0 1, or 1 0 0 0, or 1 1 1 0, or 0 1 1 0, or 0 0 1 0, or 1 1 0 1. Okay. So what is 1 0 1 1? It is 3 plus 8. It is 11. Yeah. So this is, if you are converting into decimal, this becomes 11. This is 10, 1, 8. This is 8 plus 4 plus 2. 8 plus 4. This is 14. Yeah. This is 4 plus 2, 6. This is 2. 8 plus 4 plus 1. 8 plus 4 plus 1 is 13. Yeah. So write that in ascending order. So you will get sigma m 1. 1 is there. Now comes 2. 2. 3, 4, 5, 6. 7, 8. 8. Is there 8 is there? 8. Then 8. After 8 you will get 10. 10. Then 11. 11. 12 is not there, 13 and 14. 13, 14. This we can write it as small m, m1 or m2 or m6 or m8 or m10 or m11 or m13 or m14. Okay. So that gives the min terms. That gives the min terms. Okay. So here I have discussed about standard sum of products. From each term in standard sum of products is known as min term. I have given 2 examples how to find a min term. Okay. So with that I am ending with this lecture. Okay. So here in this lecture what I have seen is sum of products form, product of sums form, truth table form of representation, and standard sum of products form. And we have also seen the definition of min term also. Okay. Now coming in the next lecture we will deal with the standard product of sums form, Venn diagram, and introduction to Karnaugh map. Okay. So by using Karnaugh map, what we can do is it is a very simple way to represent these Boolean expressions in standard sum of products form as well as standard product of sums form. Thank you, and meet you in the next lecture.